Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. An elevator cab and its load have a combined mass of 1600 kilogram. And then find the tension in the supporting cable when the cab originally moving downward at 12 meter per second is brought to rest with constant acceleration in a distance of 42 meters. Okay, so initially this elevator here is moving downward like this with the speed of 12 meter per second. Okay, and then here it will be stopped, so the final velocity will be 0 because it is stopped, right? So I'll have 0 meter over second, and the distance between initial position and the stopping position here is delta x, which is 42 meter, right? And I think we can use kinematics to calculate the acceleration here, right? So we will have to use the kinematics formula here, kinematics, which is Vt squared is equal to Vo squared plus 2 the acceleration multiplied by delta x. We know all of them except for the acceleration. Okay, so let's plug that in. We know that Vt here is 0. So I will have 0 squared, and that will equal to Vo, which is 12 squared, and then plus 2 multiplied by the acceleration multiplied by the distance, which is 42. Good. Okay, now we will have 0. And this one will be 144, and then plus we will have 84 multiplied by the acceleration, or minus 84 is equal to 144 minus 84a. Okay, so we can isolate the acceleration here, so we will have minus 144 divided by 84, which is, okay, 144 divided by 84. Okay, I will have 1.71. Okay, so I'll have minus 1.71 and meter over squared seconds. Okay, the minus sign is for slowing down, right? Because it is start from moving and it stops, so it's slowing down. So that is for the negative sign. Okay, and now we need to find out the tension, right? So we need to draw what force that work in this elevator, right? For the downward, I will have the force by the weight, right? So we will have Fw on the downward here, and then the tension will pull this elevator up, right? So we will have this one here, and this one will be the force by the tension. Good. And now we can just apply the Newton's second law. Okay, Newton's second law. And the Newton's second law said that the sum of the forces, the net force, is equal to the mass times acceleration. Okay, the positive force here is the force by the tension, so I will have Ft, which we are looking for, and then on the negative direction we will have minus Fw, which we should know because we have mass times gravity, right? So we will have this, and then this one will be mass times acceleration. Okay, we need to isolate this, so we will have Ft is equal to ma plus Fw, but then Fw is mass times gravity, right? So I have Ft is equal to ma plus mg. Okay, we know everything from the problem. We know all the numbers, right? So we will have 1600 kilogram for the mass, and the acceleration is this. Gravity, we know it's a constant. Okay, maybe let's factor out the mass here. So we'll have Ft is equal to the mass multiplied by acceleration times gravity. Okay, the mass will be 1600. And then the acceleration is minus 1.71, and then gravity will be 9.8. Good. Now I think there is nothing that we can do except plug this into calculator, right? So this will be our tension of the cable. Okay, what is it? So I will have 1600 multiplied by minus 1.71 and then plus 9.8. And I will have 12,944. So I have 12,944. And the unit here is kilogram meter over square seconds, and that is Newton. Or I think I can write it in kilonewton. So we have Ft is equal to 12.944 kilonewton. Good, and I think that is the final answer for this problem. This one or this one if you use different unit. And yeah, I think that's all for this problem. Let me know if I made any mistakes during my calculation. And thank you for watching. If you got any question, send me your problem to this email, rdsatria11@gmail.com. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.